Example 3, find the exact value. So in example 3, we have 3 examples within the example. So 1i, we are going to do sine of alpha minus beta. 2i's, we are going to do cosine of alpha plus beta, and then 3i's tangent of difference. Okay, now in your homework you will see that you will need to apply both sum and difference of sine, sum and difference of cosine, and sum and difference of tangent. But I figure if you can do one of those, you can do all of those. So that's why I'm only doing half. 3a, sine of alpha is given to you as 3 divided by 5. Then now this is really important right here. This is telling us, this is telling us what quadrant alpha needs to be in. So in here it states that alpha is in between pi over 2 and pi. So pay attention to that. So we are going to draw a triangle for alpha. Now pi over 2 and pi will put you in quadrant number 2. So right now we know right away alpha is in quadrant number 2. If we know alpha is in quad 2, we can fill out all the measurements of your right triangle. Sine of alpha is going to be opposite over hypotenuse. So this looks like a 3, 4, 5, except in quad 2, x is negative. Now let's move on to beta. They give you sine of beta is negative 1 over rad 5, which can be simplified as negative rad 5 over 5. And again, pay attention to these right here. That will tell you what quadrant beta is in. Now if you look at that, that's 3 pi over 2 to 2 pi. That tells me, I'm going to get a different pen. Just give me 1 second. That tells me beta is in quadrant number 4. So go here and put in quad 4. Now they give you sine of alpha is negative 1 over rad 5. I'm going to fill that in. This is going to be negative 1 square root of 5, and then now you have to use your Pythagorean theorem to find the adjacent leg. So a square plus b square equals c square. Your a is going to be negative 1 square, b it's unknown equals rad 5 square, and no, you can put negative 1. Technically you don't have to put negative 1 because measurements of a leg is never negative. That's why you see hypotenuse is never negative. But in trig, we are moving to different quadrants. That's why you see the y and x values are negative at times, depending on what quadrant it is in. So, but that's why it doesn't matter in Pythagorean theorem. So negative or positive 1 will give you the same result. So 1 plus b squared equals 5. So b squared equals 4. So b is going to be 2. So fill that in. Now, if you choose to use the radical 5, negative radical 5 over 5, it's going to give you the same exact answer. Now, let's move on to 1i. 1i is the difference of sine. So make sure you guys know this identity and know it really well. Now, the difference of sine is going to be sine of alpha times cosine of beta minus sine of beta times cosine of alpha. So sine of alpha, cosine of beta, I'm just going to put in my parentheses now and then find the value from the right triangle. Sine of alpha, so look at quadrant number 2. Sine is going to be, looks like I have an extra quantity here. I don't think I needed this. Okay, there you go. Sine of alpha is going to be opposite over hypotenuse, so that's going to be 3 over 5. Cosine of beta is going to be adjacent over hypotenuse, so 2 over rad 5. Take away sine of beta, so look at quad 4 again, so that's going to be negative 1 over rad 5. And go back to the red triangle, cosine is going to be adjacent over hypotenuse. So from here you can rationalize first and then multiply, or multiply and rationalize. It's really a personal preference at this point. At this level of mathematics you can choose. I'm not going to be picky as long as you know that you need to rationalize at the very end. So over here I have 5 rad 5 Now, as you can see, the denominators are exactly the same, so technically I can simplify a little bit more. So I'm going to go 2 over 5 rad 5, and yes, you do need to rationalize, so multiply top and bottom by square root of 5. This will give me 2 square root of 5 all over 5 times 5. Final answer, 2 rad 5 all over 25. And go ahead and box that up. Now cosine, 2i's, is cosine alpha plus beta. And cosine of alpha plus beta equals. So right now, if you haven't gotten this memorized, then write down the identity every time you do your homework. By the time that you're done with your homework, hopefully you will have a better memorization of all of these identities, okay? So cosine alpha plus beta is cosine of alpha times cosine of beta, take away sine of alpha, and times sine of beta. Very similar, cosine of alpha, you want to go look at your alpha triangle, in our case is red, and then beta is the green. Cosine is adjacent, so that's going to be negative 4 over 5. Cosine of beta is 2 over rad 5. Sine of alpha, go look at the red triangle, so it's going to be 3 over 5. And sine of beta is going to be negative 1 over rad 5. And away we simplify. So negative 8 over 5 rad 5 plus 3 over, oops, this 5 didn't get filled in. 5 rad 5, take away, so this is negative 5 over 5 rad 5. Simplify the top and the bottom, so negative 1 over rad 5. Now rationalize the denominator. Final answer is negative rad 5 all over 5, and box that up. Now, our last one is tangent. 1, 2, and 3i's. Tangent of alpha minus beta. Again, if you don't have this already memorized, then go ahead and write down the identity. Ours is tangent of alpha, take away tangent of beta, all over 1 plus tangent of alpha times tangent of beta. Now I'm just going to pinch this in so I can see the triangle again. I don't remember what it was. So I'm going to write down what tangent of alpha is so I don't have to go up and down, okay? Tangent of alpha is opposite over adjacent, so that's negative 3 over 4. And then tangent of beta is going to be opposite, which is negative 1 over 2. So with those two values, that's really all I needed for 3i's. I will make this bigger again and get my blue pen and fill things in. All right, here we go. Tangent of alpha is negative 3 over 4. Take away negative 1/2 all over 1 plus negative 3 over 4 times negative 1/2. And from here, let's simplify. Looks like on the numerator, I might need to find a common denominator. So this is negative 3 over 4 plus 2 over 4. On the denominator, I don't need it quite yet. I'm going to multiply. Negative 3 times a negative 1 is positive 3 over 8. On the top, now I can do, okay, negative 1/4 all over LCD. This is 8 over 8 plus 3 over 8. So that will give us negative 1 over 4 all over 11 over 8. Now technically, I'm going to do this old school, negative 1/4. When you are dividing, you multiply by its reciprocal, so 8 over 11. And as you can see, we can go, oh, whoop, 1 and 2. We can cross simplify, that's negative 2 over 11. Now, if you can go from here, if you can see that, okay, these two fractions are just dividing each other anyway, you can definitely simplify that way. So if you can see that this is really now negative 1 over 1 divided by 11 over 2, then all you do is, what happens when you have a 1 divided by a fraction? All you do is really flip this fractions and you would get the same answer. That's just another way of doing that. Anyway, you can definitely take the denominator and flip it, okay? But if you choose to go this route over here, that's also okay. Now we have another example here on the next page. I gave you plenty of space. Sometimes I write really big, so hopefully you guys have enough room for all of these. B, under the same instruction, okay, so you have first, let's figure out what quadrant that is and what quadrant that is. So I'm going to draw my right triangles out. Alpha, this is beta. Okay, so cosine of alpha is 1/2, and it says alpha is negative pi over 2. Now remember, negative pi over 2 is going this direction, so that is in quad 4. I would now go in and draw my right triangle in quad 4. Now cosine is adjacent over hypotenuse. Because I need to use Pythagorean Theorem, a squared plus b squared equals c squared. 1 squared plus b squared equals 2 squared is 4. b squared equals 3. So b equals square root of 3. So this is square root of 3, but because you are in quad 4, your y value is negative. Similarly, and sine of beta is 1/3, and they give you beta, it's from 0 to pi over 2, so that's in quad 1. Sine is opposite over hypotenuse, so a squared is 1 squared plus b squared equals 3 squared. So this is b squared equals 8 because 3 squared is 9, 9 take away 1 is 8. b squared is square root of 8, which you do need to simplify down to 2 rad 2. So 2 rad 2. Because this beta triangle is in quad 1, all of these sides are positive. Okay, so let's move on to 1i, which is, as you remember, it was sine of alpha minus beta. Can you do me a favor and write out the identity before we start? If you haven't done it, can you hit pause and do it? Write out the identity. Okay. All right, now that you have tried to write out your own identity, I will now write mine here to see if we agree. Okay. Okie dokie. Hopefully we are matching. Another way that I sometimes like to do as well is because I know I need sine of alpha and cosine of beta and sine of alpha and so on and so on. So what I normally like to do is I write them out first. Okay, so sine of alpha is, and then that way I don't even have to think about it. Okay, then cosine of alpha is 1/2. Then over here, same thing. Sine of alpha, not alpha over here, this is beta. This is beta equals 1/3, and then cosine of beta equals 2 rad 2 over 3. Now we can go even a step further because in 3i we need tangent, so we can go opposite over adjacent. We can simplify that later. Same thing over here. Let's do that as well. Tangent of alpha is opposite, which is negative rad 3 all over 1, which is really negative rad 3. Okie dokie. Now that we have all of those, I can move up and just fill it in, right? Sine, cosine, cosine, and sine. And we wrote them all down. Now we just have to find them. This is going to be negative rad 3 over 2. Cosine of beta is going to be 2 rad 2 over 3. Cosine of alpha is going to be 1/2. And sine of beta is 1/3. Okay, let's multiply. This is going to be negative 2 rad 6 all over 6 minus 1 over 6. Now, if you think about it, you can simplify these, okay? But I'm not. What I want you to do is all of your answers, I want it over one common denominator. So we are just going to write the numerator together just like that. Technically, you can box that up. Another answer is you can take out the negative in the front here, or it's the -1, that is. And you can write 2 rad 6 plus 1 all over 6. Okay. All right. Either one I will accept. Now let's go and do 2i. 2i was cosine of alpha plus beta. what I want you to do is I want you to do this question on your own and give me the answer here at the bottom. Can you hit pause and try that on your own, please? We have one last one on this example. It was a tangent of alpha minus beta. So just like before, why don't you take a minute and write down the identity for tangent minus beta. Feel free to hit pause, please. Okay, now that you have written it down, let's compare to see if we match. Okay, hopefully we're matching up. Now earlier I wrote tangent up here, but I'm going to copy it back down so that way I don't have to move up and down. So we knew tangent of alpha was negative rad 3, and then we wrote tangent of beta was 1 over 2 rad 2. Now if we feel like rationalizing this right now, we can multiply top and bottom by rad 2. So that's rad 2 over 2 times 2, which is really rad 2 all over 4. So we can use this one and rationalize later, or this one right away. Really a personal preference. Okie dokie, let's fill it in. Let me stretch this out. Okay, so tangent of alpha is negative square root of 3 minus, I'm going to use square root of 2 over 4, the rationalize for tangent of beta. So square root of 2 over 4 all over 1 plus negative square root of 3 times square root of 2 over 4. Common denominator for this little guy is 4, so now that's really negative 4 rad 3. The denominator is still 4, so this is negative 4 radical 3 minus rad 2. Now notice how I did not combine the radicals because they are not exactly the same. On the denominator, I will now have 1 minus radical 6 all over 4. When you multiply, you can definitely multiply different radical. It's just when you are adding or subtracting is when you may not. I will now change this 1 into a denominator of 4, so a 1 becomes a 4 over 4. So let's go a step further. Negative 4 radical 3, take away rad 2 all over 4. Okay, I'm going to move my page over. Divided by 4 minus rad 6 all over 4. Now as you can see, I can get rid of these right away. I don't need to worry about because when you're dividing, those are exactly the same. You can cancel those. Now if you want to change it to multiplication and flip the denominator, as you can see, that will also cancel that out. So all I now have is negative 4 radical 3 take away radical 2 all over 4 minus radical 6. And yes, you must rationalize your denominator. So this has two terms. It's a binomial. To rationalize all binomials with one radical term, you will now need to multiply by the conjugate of the denominator. So the conjugate is changing this sign to be its opposite on just the denominator. Remember, you're only changing that middle sign. You don't change the sign in the front. So that's a conjugate. So when you multiply to the denominator, you will multiply to the numerator and distribute. Now, what's nice about conjugates is that you don't need to multiply the two terms in the middle. You don't need to do the terms in the middle because the signs are opposite. So when you do opposite sign, they cancel each other. So conjugates mean you only need to multiply the first two terms and the last two terms. Radical 6 times radical 6 is rad 36, which is really just back to 6. Now on the numerator, they are definitely not conjugates, so I will FOIL everything out on the numerator, moving that up a tad bit. Hopefully you have more space than I do currently. I might need to pinch it in and try to squeeze that in somehow. Okay, so this guy. Negative 4 rad 3 times 4, negative 16 rad 3, negative 4 rad 3 times rad 6, that's negative 4 square root of 18, You already have that, so I'm going to do that guy right there. Keep on going. Numerator, negative rad 2 times 4, that's minus 4 rad 2. And last, that's going to be negative rad 12. I'm going to find some space. Can you see if I were to... Okay, I'm going to move it down here, and then I will move it back up. Okay, so now on the denominator, I'm going to move it all the way over here. The denominator is not bad, that's just 10. Then I have negative 16 radical 3 minus 4. Rad 18 is really 9 times 2. Then minus 4 rad 2. Rad 12 is really square root of 4 times 3. As you can see, I'm trying to write everything out so we can simplify. So this is negative 16 rad 3. This is really 4 times 3 rad 2. This is 4 rad 2. And then this is really 2 rad 3. All over 10 again. We can combine those two dudes right there because those are both with radical 3. So that will give us an answer of negative 18 radical 3. We can combine those two guys. That's a negative 12 rad 2 and a negative 4 rad 2. So that's going to be negative 16 radical 2 all over 10. On the numerator, I'm going to take out a 2 because it's even. So that's negative 9 rad 3 minus 8 rad 2 all over 10. The reason I factor it out because I know I can simplify this, right? And I believe that is our final answer. This is negative 9 radical 3 minus 8 radical 2 all over 5. Okay, and if you want to take out the negative sign and write it in the front, I'm okay with that. No big deal at all. Okay, now if you see in your textbook that they write it like this, if you see in the textbook, they have the negative in the front. If you just see this negative in the front, that means it is applying to both terms on the numerator. So make sure this negative is lining up with this bar. So whenever you're checking your answer and you see that negative sign in the front lining up with the fraction bar, that means it's applying to all terms on the numerator. Here we go. Find the exact value. Okay, so let me ask you this question. Exact value. Calculator or non-calculator? I hope you said non because it has to be non-calculator. Okay, so A, sine composed with sine inverse of radical 3 divided by 2 plus cosine inverse of 1. There are so many different ways of writing these or finding the answer for these. You don't feel obligated to do the way I do it. If you know another way that's easier for you, you know what? Do that way. But the first thing I'm going to do is I'm going to let this one right here, see that right here, be alpha. And let this guy right here be beta. Okay, so let's do alpha first. Since alpha is a sine inverse, I know there's a restriction. Sine inverse, it's either in 1n and 4 because that's sine inverse and that's positive radical 3 over hypotenuse. I now know that's in quad 1. Cosine beta, it's also restricted. It's in quad 1n and 2. Because I know that's positives, I know it has to be right here. Okay, so cosine inverse of 1, it's right here. Okay, so let's go and find sine. You got sine, okay, of sine inverse of radical 3 over 2 plus cosine inverse of 1. But we already know that this is alpha and this is beta, right? So let's use your identity. And I meant beta. Okay, and the identity said, hey, what's the identity? Can you help me write that out? Sine of alpha, cosine of beta. Good, so far so good. Plus cosine of alpha times sine of beta. Okay, well, I have alpha and beta. I know exactly where to look for alpha. Alpha is a black triangle. Sine of alpha is radical 3 over 2. Cosine of alpha, I can also look at the black one. Cosine is adjacent over hypotenuse. Beta, cosine of beta. Beta is a blue one. Cosine is 1. Sine is 0. And then in the middle, I need to bring down that plus sign, otherwise it's going to be wrong. Okay, so when I multiply, 1 times radical 3 is just radical 3. All over 2. 0 times anything is 0. So my final answer for this one is just radical 3 over 2. Okay. Now, could you have worked this one out differently as well? Of course. Of course you could have worked this one out differently. But that's just one way. And I will show you a different way soon. Okay. Draw a line. Okay. So similarly, I'm going to go through and assign each one alpha and beta. So this whole thing right here, I'm going to call it alpha. And this whole thing right here, I'm going to call it beta. Then I'm going to draw a triangle here. Sine is restricted in 1 and 4 is positive. I'm going to put opposite over adjacent. This is 3, 4, 5. Beautiful. This is alpha. Then I'm going to draw beta. Cosine is restricted in 1 and 2 is positive. I'm going to put it in quad 2. It's adjacent over hypotenuse. This is 5, 12, and 13. This is one of the special triangles as well, right? So this is 5. Okay, cosine adjacent over hypotenuse. Okay, so let's work this out. Are you ready? I'm using cosine of alpha, which is the black triangle, plus beta, which is the blue triangle. Do you know what the identity is? Can you help me write that out? Okay, let's write it out together. I'm going to use green, okay? Cosine of alpha times cosine of beta. In cosine, we switch, okay? If it's positive here, we make it minus here. Sine of alpha times sine of beta. All right, now we will just go and look at the triangle. Cosine of alpha, alpha is coming from the black triangle, so cosine is 3/5, okay? Cosine of beta, beta is coming from the blue triangle, so I'm going to use blue ink. Cosine is 12 over 13. Then I'm going to have a subtraction sign in the middle. Sine from alpha, alpha is going to come from the black one, so I'm going to use black ink. Sine of beta, beta is coming from the blue one, so sine is 5 over 13. Let's multiply. So from here, 3 times 12, that's 36. 5 times 13, that should be 65. Take away 4 times 5 is 20, divided by 65 as well. Okay, let's plug in some more. 36, take away 20, that's 16, divided by 65. Do you think we can reduce this? It's not divisible by 5 on the top, so, and 16 is an even number, so it can only be reduced by 2, right? Or multiples of 2. So right now we can't really reduce that, okay? All right, on the last one, why don't you decide which one's alpha and which one's beta, and then draw at least 2 triangles for me, one for alpha and one for beta, and then we'll come back. Okay, did you go decide alpha and beta and draw out the triangle? Okay, so again, I make this my alpha just because it's the first one. Okay, and make this my beta. All right, alpha is sine inverse of 2/3, so I'm gonna put that alpha in quadrant 1 with black ink because I circled it back. Okay, so black ink for alpha. Okay, and sine is opposite over hypotenuse, so let's do Pythagorean. A square plus b square equals c square. A square is 2 square plus b square is unknown. We'll leave it as is, 3 square. So this is 4 plus b square equals 9. So that's b square equals 5. So this is rad 5, okay? So b equals rad 5. All right. Now tangent, if you look at tangent, tangent is beta, but it's negative. So guess what you have to draw it in? Quadrant number 4. Opposite over adjacent. Well, tangent is negative 3/5, so I need a little bit more space here because I need to write -3, right? And this is the 3, 4, 5. Oh, at least that's nice. Okay, so this is beta. Okay, so now let's go and use cosine, right? Here we go. Cosine of alpha plus beta equals, can you write down the identity for me? You want to write down the identity each time, so that way by the time we take a test, it's already in your head. You do need to have it memorized, all of these, okay? So it's going to be cosine of alpha, cosine of beta, minus sine of alpha times sine of beta. All right, here we go. I'm going to see if I can plug it in, okay? Cosine of alpha, alpha is a left black triangle, so I'm going to use black ink here. Cosine is adjacent over hypotenuse. Beta is my blue triangle, and it's cosine of beta, so it's 4/5. And then take away sine of alpha. Again, alpha is a black triangle, so I'm going to use my black ink. So 2/3. And sine of beta, beta is -3/5. So those are the ratios of the triangles. And now we just have to multiply it out. This is 4 rad 5 all over 20. A negative times a negative is now a positive. A positive 6 over, why am I saying 20? 15. See how I can't multiply? Okay. I can't add, I can't subtract. Okay. So this is 15. Well, the denominators are the same and the numerators we can't do anything at all. So what can we do? Nothing. Am I right on that one? Nothing at all. Okay, here we go. So just 4 rad 5 plus 6 all over 15. Even if the top I can factor out the 2, it's not going to help me reduce, so I'm just going to box it up. Example 5. Established each identity. That means we're going back to proofs, okay? So, but before I start writing the proofs, let's write out all of the identities that we know already. Identities that we already know. Let's start with the basic, right? Cosine square of theta plus sine square of theta equals 1. Okay, so we'll bubble this up. Okay. Then keep in mind that we can divide each and everything by cosine square. So 1 plus tangent square of theta equals, if I divide 1 by cosine square, that's 1 over cosine square. So it's really secant square of theta. Then I can do the same thing by dividing each and everything by sine square. So that's really cotangent square of theta plus 1 equals 1 over sine square is now cosecant square of theta. So that's old, right? We still need to know it. Now the new one, the sum and difference, is cosine of alpha plus beta equals cosine of alpha times cosine of beta. I need more space, so let me erase this. Okay. All right, so in cosine, we switch. Okay, so now it's sine of alpha times sine of beta. Okay, well, I also have what, subtraction as well. So instead of writing it over, I'm just going to go in and subtract. Well, now in subtraction of cosine, we now have an addition in the identity. Okay, we also have sine, don't we? So sine of alpha plus beta is sine of alpha cosine of beta. Oops, I need to erase. I need more space. Okay. So now in sine, we're going to keep it the same. Okay. So sine of alpha cosine of beta times cosine of alpha times sine of beta. Now, what if I want sine of alpha minus beta? Then I'm just going to minus the identity. Then, of course, we have tangent. Okay. So tangent of alpha plus beta equals, now tangent is going to be addition on the top if it's a sum of tangent, okay, and then divided by, so let me erase some more. Looks like I'm always in needing of space. Okay, so now I'm going to have a 1 because it's already added on the top. This is minus tangent of alpha times tangent of beta, so keep that in mind. Well, of course I have subtraction, right? This is the difference of tangent. If that's the difference, this is the difference here on the top, and this is an addition on the bottom. So those are all of the identities that we now have, okay? So let's start with our letter A. Cosine of pi over 2 plus theta equals negative sine of theta. Remember, the guidelines for writing proofs are still the same. You're going to pick the side that looks scary, right? In this case, this is cosine of pi over 2 plus theta, because this has a lot more things going on. And this is your goal right here, okay? My goal is to change that somehow to negative sine of theta. Well, this is, think of this as alpha plus beta. So I'm going to use that. So that's really cosine of alpha plus beta, which is by identity, cosine of alpha, cosine of beta, minus sine of alpha and sine of beta, because that's the identity that I'm about to use. Then step 3, instead of alpha and beta, I really have pi over 2 and theta. Okay, so now that means I'm going to use this right here and substitute that with, this is now, this is no longer alpha, but it's pi over 2. So that's cosine of pi over 2. Then this right here is cosine of theta. Cosine of theta. Take away. Now alpha is really pi over 2. So sine of pi over 2. Okay. Beta is really theta. And then that's what I'm doing. Okay. Then step number 4. Now cosine of pi over 2. Let's recap a little bit. Okay, if you remember, cosine of pi over 2 is right here. Cosine is going to be what? 0. And yes, you write it down. You don't assume that I know anything about trig. Minus sine of pi over 2 is same spot, right? So sine of pi over 2 is 1. Yes, you write the 1. Okay. Then our very next step, well, 0 times anything is 0. Okay. Then if that's 0, what's left over? If that's 0, I just have negative 1 times sine is negative sine of theta. And that is my goal. You give me your initial to tell me that, you know what, teacher, I'm done. I got this, okay? And then that's how we write the proofs. Now, writing proofs in 7.5 is much, much easier just because all that is just using the identity, okay? Let's do B. I'm going to use different ink here so that way it doesn't kind of go crazy with my identities in the middle. Okay. B. Again, I'm going to pick tangent of 2 pi minus theta because that looks scarier. And look at the goal. I want to get to negative tangent. Okay. Now, this is what I don't want you to do ever. Please don't do this. I would cry. Okay. Tangent of 2 pi minus tangent of theta. Okay. That's not okay. I will cry. Okay. All right. So But now that you have this, I will now use an identity. Are you ready? Can I use tangent of alpha minus beta? Okay, so the identity says here, look, I already have it written for you. Woo! So from here, I will use my identity. Here we go. Tangent of alpha minus tangent of beta all over 1 plus tangent of alpha times tangent of beta. Okay, well, this is really alpha and this is really beta. So I'm just going to plug it in. So here we go. Step 3. Alpha is really 2 pi. So tangent 2 pi. Minus beta is really theta. All over 1 plus tangent of 2 pi times tangent of theta. Okay. Well, let's find out where 2 pi is. Okay. 2 pi is 2 right there, okay? Tangent, and that location is 1, 0. Tangent is y divided by x. So if you think about it, it's really 0 divided by 1. So tangent of 2 pi is 0. That's right. Okay, so step 4, 0 minus tangent of theta divided by 1 plus, yes, you write all of this out again. All right, so here we are, okay? Well, would you agree? Oops, I'm sorry, this is meant to say 0. All right, well, would you agree that 0 times anything is 0? So now, step 5, 0 minus tangent is negative tangent of theta divided by 1. So that means step 6 is really negative tangent of theta. And do my happy dance. Okay, so as you can see, if you know the identities, then writing proofs in 7.5, it's really a piece of pie. Ha ha. Pie, get it? Let's start with my toddler joke of the day. Okay, the toddler joke of today is, why did the TV cross the road? Why did the TV cross the road? Because it wanted to be a flat screen. Ha ha. All right, here is example 6. Write each trigonometric expression as an algebraic expression containing u and v. Give the restrictions required on u. So let's start with example A. Now, keep in mind, this example 6 is very, very similar to example 4. See this example 4 from previous videos? But instead of numbers, it just has u and v, and that's not really important. If you understand the concept, then it's not a big deal. Okay, so let's recap what we did in example 4 to give you an idea. So in example 4, remember we let this one be alpha and this one be beta right here? We're going to do the same thing. Okay, this is alpha, okay, and this is beta, and we draw 2 triangles. Sometimes you can't draw a triangle, then just make a dot. Here we go. So let's make this right here. Let alpha be sine inverse of u. So this is alpha. Then because it's just a variable u, technically I can draw it in quadrant 1 or 4, but why put things in quadrant 4 when I have to deal with negative, where I can just use quad number 1? Sine is going to be opposite over hypotenuse. So I have to do a little bit of work to find the adjacent. Okay, so it's going to be a squared plus b squared equals c squared. Well, c squared is 1. A squared is, let's say, u squared plus b squared. So I'm going to solve for b. So b squared equals 1 minus u squared, square root. So as you can see, b is square root of 1 minus u squared. Now, I know because I put it in quad 1, everything is going to be positive. Okay, so that's alpha. Now, I'm going to need to also draw another one for beta. Okay, so let's make this, what ink? Black ink. Here's beta. Let beta be cosine inverse of v. And again, because v is an unknown variable, you can draw this in quad 1 or quad 2 because that's the restriction for cosine inverse. But why make it difficult, right? So cosine is adjacent over hypotenuse. So I need to find this. And it's the same basic math like over here. So here we go. It's going to be a squared plus b squared equals c squared. C squared is 1. This is v squared plus b squared. So when I subtract both sides, I have 1 minus v squared. So b is going to be square root of 1 minus v squared. So we're going to put 1 minus v squared. Cautiously, okay? I don't want you to write fast because the u's and the v's, they look the same. But when you put them together, you can't multiply if they are u's and v independently. So what am I doing? I'm really now writing sine of alpha plus beta. Okay, so sine of alpha plus beta, which from my identity, yes, write down the identity. I'll wait for you to give you a minute to get a head start, or maybe 10 seconds to get a head start, and then I'll catch up with you with just the identity. So right now, just give me the identity. Okay, so hopefully this is what you wrote. Sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. Okay. Well, I have alpha. Alpha is this one, and I have beta. Beta is this one. Then now I just have to plug it in. Okay. So sine of alpha is, sine is opposite over hypotenuse. Cosine of beta is, beta is over here, so cosine is adjacent over hypotenuse, plus cosine of alpha. Alpha is over here, adjacent 1 minus u squared over 1 times, okay, sine is over here, have opposite 1 minus v squared over 1. Well, it looks like everything is over 1, right? So let's get rid of the ones. Okay, so it's u times v plus radical 1 minus u squared times radical 1 minus v squared. Well, guess what? There isn't much you can do, right? So technically you can box this up, and if you feel like multiplying these in the radical, you can do that too. I'm about to sneeze, so hold on tight. Excuse me. Okay. Well, you don't have to because you can't really simplify. So even when I put it under one radical like this, and yes, that's the same, okay? Guess what? I can't really simplify to make it any prettier. So I will accept 2 separate radicals or 1 big radical. It's really up to you. And that's kind of how we use u and v for this one. All right, let's move on to example 2. I'm sorry, not 2b. Okay, here we go. Well, secant of tangent inverse of u plus cosine inverse of v. And I'm going to let this be alpha and this is beta. Okay, so let's draw a triangle. Tangent inverse is restricted in 1 and 4, but because I want it to be positive, so I can put it in quad 1. So here's alpha. Tangent is opposite over adjacent. So based on Pythagorean theorem, let's try that. Okay, so it's a squared plus b squared equals c squared. C squared is unknown, so 1 squared is 1, plus u squared is u squared equals c squared is unknown. Let's solve for c, so c equals square root of 1 plus u squared. That's where we're going to put this 1 plus u squared. All right, so there's alpha. Let's draw beta. Beta's over here. Okay, here's beta. Cosine, it's restricted. Cosine inverse is restricted in 1 and 2. I want everything to be positive, so let's put it over here. Cosine is adjacent, which is v over hypotenuse. Okay, well, we kind of did this already over here. See this right here? So I know, based on my basic math over here, this is now 1 minus v squared for the opposite leg. So I'm dealing with secant, so I'm going to start with secant of alpha plus beta. But Mrs. Tran-Bloom, you never gave us any identity for secant. What the heck, hey? Well, I don't need to. Why should we all need to memorize another formula where I can just use something we already know, like cosine. Secant is 1 over cosine, and yes, it's the same, okay? So we just have to carry the 1 on top the entire way, okay? So let's keep on going. The identity for cosine is cosine of alpha, cosine of beta, minus, because you have to do, and then remember, you have to extend this line, otherwise it's not correct if you don't extend this line. So minus sine of alpha, sine of beta, okay? Then we find the cosine alpha plus beta normally and then just put it over 1. That's exactly all that is. So let's keep on going. 1 over, here we go. Cosine of alpha, alpha is my red triangle right here. It's going to be 1 over the hypotenuse. Oh no, the hypotenuse is ugly. Hypotenuse is radical 1 plus u squared. That's its cosine. Times cosine of beta. Cosine of beta is nice. It's adjacent as v over 1. Beautiful. Minus sine of alpha, back to the red triangle. Sine is u over hypotenuse, and there goes that ugly hypotenuse again. Okay, extend this line. Sine of beta, it's 1 minus v squared all over 1. Okay, so let's multiply this out. It doesn't look cute, but what choices do I have, right? It's 1 over, here we go. I'm going to multiply these, so let me highlight. 1 times v is just going to be what? V over my denominator of 1 plus u squared, okay, minus u times square root of 1 minus v squared. Write the v's and u's carefully, because if you don't, you will do the wrong math, because we have to find common denominator if they're not the same. Oh, nice. Look at this denominator. It's already the same, right? So I can just 1 divided by, okay, put it all over the same denominator because it's exactly the same. Cool, right? Okay, so now on the top it's just really v minus u radical 1 minus v squared. Okay, so 1 divided by anything, it's really like this. 1 divided by, all right, v minus u times square root of 1 minus v squared all over square root of 1 plus u squared. I can multiply by its reciprocal, so here we go. Well, if I multiply by its reciprocal, 1 times this is now just that, okay? So v minus u times square root of 1 minus v squared. Okay, so technically, this is an answer. Would you agree? If this is on a test and you get down to here, I will give you full credit, okay? Because look at that, that's just a lot of work already. So again, I'm just going to highlight this and tell you right now, if you are able to get to here, you will get full credit. Okay. Now, if it's a multiple choice, you might need to rationalize your denominator. So this is the part where if it's a free response, the credit is full. If it's multiple choice, you need to be able to know how to rationalize to get to an answer with no radicals. So this is where I'm going to come in and multiply by the conjugate. Hopefully it's not some ugly answer. We'll see, right? Okay, so what I multiplied to the bottom, I now multiply to the top. Okay, then now I'm just going to cautiously and carefully write down everything, because I tend to make algebraic mistakes and I don't want to do it. Okay, so let's do the top one. The square root 1 plus u times that is going to be v in the front times square root 1 plus u squared. Square root of that times that is going to be an addition of u times 1 plus u squared times the square root 1 minus v squared all over. On the bottom, because these are conjugates, I can just v times v is v squared minus u squared times radical 1 minus v squared times another radical 1 minus v squared. The radicals go away. So that's where I'm at right now. Okay, I'll pause a little bit so you can copy it down. Okay, so now we're just gonna see if we can do anything to simplify, right? So let's check. This is v times square root of 1 plus u squared on the top plus, technically you can keep these two right here as their own radicals, or you can multiply and put it under one common radical like this. Okay, either way, they are the same. All over, okay, on the bottom, v squared, I'm just going to distribute this, okay, minus u squared times negative u times a negative u squared times a negative v squared is positive u squared v squared. Well, not much you can do, so guess what? That is my final answer. Look how ugly that is, right? So that's why, like I said, I will give you full credit if you are able to get down to here. Okay, so this is okay. Either form slash answer, it's okay. Okay, unless you are in multiple choice and they need to get rid of the radical, then you have to go further. Okay, okay, this is the end of our example. All right, guys, this is example 7 in section 7.5. Yay, it's the last one. Okay, all right, so all right, why not start with my toddler jokes, right? Let's see. Why did Mickey Mouse go to outer space? Why did Mickey Mouse go to outer space? He was looking for Pluto. If you don't know, Pluto is his dog. Okay. Okay, so here we go. Example 7. Solve each on the interval of 0 to 2 pi inclusive. Okay, so keep that in mind because it's including 0 and 2 pi can have both. Your book, though, might have a different set of directions. Okay, if it says like solve from 0 to 2 pi, not including 2 pi, then you can't have 2 pi. Let's review a little bit from Algebra 1. Review Algebra 1, okay? What if I said, let's say, what can I have? Let's give you this. X squared equals 9. What is x? X squared equals 9. What's x? Okay, most of you said, okay, well, I would take the square root. That's correct. And most of you said x equals 3. Well, that's partially correct. Okay, because technically, couldn't x also be negative 3? Okay, so you should have both. Okay, and that's why we have, anytime you take a square root, there are 2 of them. Now, what if I said, what if this is the true statement? Okay, what if x is 3? Okay, this is my original question. Okay, so because x is 3, would you agree that I can't do anything because that's the only question that can have? But what if I go in and square both sides? Okay, then would you agree that this is x squared equals 9? Okay, that is true, right? It's true and true. Okay, but here's my question. And I said, well, from here, I would like for you to solve. Okay, well, when you take a square root, you take a square root, x comes back down to, well, you take a square root. There are 2 of them. But what's wrong with this answer? What's wrong with this answer? Remember, the original question is not square, right? So when you square it and you went back and solve for it, see there's an extra answer? Extra answer because you square it. Okay, so I want you to look at this. Okay, this is a true statement. This is a true statement. Okay, but when I solve for this, see this right here, I ended up with 2 answers, but my original statement was only 1. So in algebra, we are manipulating equations so we can solve. Like we borrow things, we manipulate things. Okay, we substitute with an identity so we can solve. But when you solve, don't forget to check the answers. Okay, so let's keep that in mind. Don't forget to check the answers. So let me spell that out. Check answers. Okay, here we go. So our first equation is quantity sine of theta plus cosine of theta, all of its square equals 1. Most of us would write this out twice, right? Most of us would write this out twice and then multiply. Of course, you can do that. There's nothing wrong with that. Okay, so here we go. Equals 1. Okay, let's FOIL cautiously. Sine times sine is sine square of theta. Sine times cosine is sine times cosine, because there's not much I can do with that. And then in the middle, there's another one, sine times cosine. And then cosine times cosine is going to be cosine square of theta. And then equals to 1. Okay, well, look. Okay, I can put those together and I can add these together. So now I have sine square of theta plus cosine square of theta. In the middle, I have 2 sine cosine. Okay, equals 1. Well, this is an identity. I can substitute that. So here we are. Okay, I'm gonna see if I can move the ones. Oh, so when I move the 1, okay, I now have 2 times sine of theta cosine of theta equals 0. Okay, well, this is like a factor. See that right there? So I can take each factor and set it equals to 0 because it's, okay, perfect. Okay, so now divide both sides by 2. Well, 0 divided by 2 is 0. So cosine of theta equals 0. Cosine of 0 is here and here. So that's pi over 2 and 3 pi over 2. Okay. Oops, I'm sorry. That's 2 sine of theta. My bad. Change that. So that means my answer is going to be different here. Sorry, I jumped the gun. The cosine's on the other side. Okay. So this is 2 sine of theta. 2 sine of theta equals 0. 0 divided by 2 is 0. So sine of 0 is here and here. So that means it's 0 pi, and because 2 pi is included in this restriction, I have to write 2 pi. Now cosine of 0 is here, which I did this earlier. That's sort of pi over 2 and 3 pi over 2. So would you agree, it looks like we have 5 answers, right? Theta is, let's start from small to big, 0, pi over 2, pi, 3 pi over 2. And because 2 pi is included in my instruction, I want to write down 2 pi. But the question is, can I keep all of this? Okay, so let's go back and check them. So let's start with the first theta, which is 0. Okay, here's check. Okay, so my original question is sine of theta plus cosine of theta, all of this square equals 1. Then my first angle is 0. So sine of 0, oops, I write it like theta, but it's supposed to be 0. Sine of 0 plus cosine of 0, 0 is an angle, square, question mark, equals to 1. Well, sine of 0, here's 0, sine of 0 is 0. So 0 plus 1, everything square equals 1. Checked, I can keep 0. How about pi over 2? Okay, and then we go, hey, sine of pi over 2 plus cosine of pi over 2, everything square equals question mark 1. Well, cosine of pi over 2 is 0. Sine of pi over 2 is 1. 1 square is 1. Check, I can keep that. How about pi? Sine of pi plus cosine of pi, everything square equals question mark 1. Well, sine of pi is 0, so that goes away. Cosine of pi is negative 1. Remember, everything's square. So check, I can keep that. So what's going on? Looks like I can keep all 5 answers because the deal is that this is being square right here. You see this right here? And anytime that you have anything being square, all the negative will become positive. So that's why I can keep all of these. All of that is my answer. Okay. Okay. So don't forget to check. Okay. So let's do example B. Example B, we will use a different ink here. Now, please don't be mistaken that this is not 1, okay? Not 1. So the only time that you can change that into 1 is when it's sine square of theta plus cosine square of theta. This is 1, okay? All right, so how would I solve that? What would you do? Right now, honestly, there's not much you can do. So the first step is I'm going to square both sides. Like that, okay? If I square the right, I can square the left, and yes, that still be equal. So since I square both sides, this is what I now have. Wow, doesn't that looks like part A after squaring both sides? Yes, it is, okay? So it does. So let's start solving. Well, but if it looks like part A, couldn't I just use the same answer as part A? Yes, you can. You can have the same solutions at the bottom like part A. But you know what? Since this is notes, let me teach you another way of solving. So let's use purple, okay? In part A, I solve for it by multiplying it out. But what if I want to solve for it by doing this? Okay, taking the square root. Is that okay to do? Well, some of you would totally start that way, right? Okay, well, let's try. If I take this square root, I now have sine of theta plus cosine of theta equals positive and negative 1. Then I'm going to go like this. You know, teacher, I would write it out like this and set this equal to 1 and write it out like this and set this equal to negative 1. Is that okay to do? Please don't do that, okay? That only works if it equals to 0 and you have factors. So please don't do that ever, okay? So as you can see, what happens when you take the square root? You are back to the original, okay? So keep in mind, the only way to solve for it is really multiplying it out, okay? Your identity all have squares. So when you multiply it out, okay, then they become square terms and you can use your identity. So keep in mind, you may not do this ever, okay, unless it equals to 0. Now, let me talk to you about what to do next, okay? So we solve for it the same way. Solve for it the same way as part A, okay? When you solve for it for the same way, you have theta equals 0, pi over 2, pi, 3 pi over 2, and 2 pi. But keep in mind your original equation, okay? Original equation was sine of theta plus cosine of theta equals 1. We square both sides so that way we can manipulate the equation to solve, but that's not the original. When you check, you need to go back to the original, okay? So check. When sine is 0, so let's plug in. Sine of 0 plus cosine of 0, is it question mark equal to 1? Well, sine of 0 is 0, so that goes away. Cosine of 0 is 1, so 1 equals 1. Check, I can keep that one. How about when is a pi over 2? Sine of pi over 2 is 1 plus cosine of pi over 2 equals question mark, is it 1? Well, cosine of pi over 2 is 0. Sine of pi over 2 is 1, so that it's okay. How about pi? Sine of pi plus cosine of pi equals question mark 1. Sine of pi is 0, so that's okay. Cosine of pi is negative 1. Negative 1 does not equal to 1, so I can't keep that. So you see the difference between A and B? So, and then how about 3 pi over 2? Kind of the same thing, right? So sine of 3 pi over 2 plus cosine of 3 pi over 2, question mark, is it 1? Well, cosine 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. Negative 1 does not equal to 1. Okay, so that doesn't work. How about 2 pi? Okay, so sine of 2 pi plus cosine of 2 pi equals question mark 1. Well, this will work because cosine 2 pi is positive 1. So this one, part A, has all 5 answers. What gets going on with part B? There are only 3, 0, pi over 2, and 2 pi, and these are the only ones that you can keep. So let's see the difference, right? The difference that in part A, we didn't have to square both sides. So that's why there were no extra answers. But in part B, we had to square both sides so we can manipulate the identities to solve. So when you square both sides, let's go back to this thing right here, right? When you square both sides, what's going on? You have extra answers. So the rule of thumb is when you square both sides, you should always check your solutions, okay? So when squaring both sides to solve, check final set of solutions, because you have created extras, okay? Because you square both sides, now you have created extras. That means you need to test which one are the extra ones that don't belong in the original, okay? All right, so this is the end of our 7.5. Yay!